Question 1. A is the point with coordinates 2, 10, and B is the point with coordinates 5, D. I think it should say A is the point with coordinate, I don't know, but it's the plural, so it doesn't really matter. It says the gradient of AB is 4, which means it's going uphill, so I think that diagram is a reasonably good diagram. So it's a nice positive gradient. That's my effort at line, which I'll do again because that's pretty bad. That's a bit better. And what we'll do is we'll see how much the x has gone up by. Well, the x has gone up by 3. But what's the difference here? Well, the y coordinate here is d and the y coordinate here is 10. So that distance will be d minus 10. So for example, if d was like 11, the distance would be 11 minus 10, which would just be 1. But in this case, it's just d minus 10. So the gradient is the change in y over the change in x. Another way of looking at the gradient is, and I like teaching this to my students, and that is if you make this 1 by scaling the triangle down by a factor of 3, then for every 1 you move along, what you go up by is your gradient. So the gradient here is just d minus 10 divided by 3. And that's equal to 4 because it tells us that here. So what do we do next? Well, we just solve the equation. So times both sides by 3 and add 10. So D is 22. Question 2. Sophia pays £222 for a plane ticket. She also pays €100 for the airport tax. We're given the exchange rate here, and we've got to find what percentage of the total cost of the ticket and the airport tax does Sophia pay for the airport tax. So I think we've just got to do this sum here, to be honest, and then change this fraction into a percentage. So if you see what I'm doing here, so 100, that's in euros, and that's for the airport tax, and I'm just going to convert this £222 into euros. So I'm going to do 222, just get this calculator on, 222 times 1.38, so that gives me 306.36. That should have gone up here, so I'll just do the denominator as 406.36. So if I do that, times it by 100 to turn the decimal, which I'd get here, into a percentage. So let's see what we get. So we've got 100 divided by 406.36. That's 0.246 and so on, times 100, which will make it a percentage, and we want the answer to one decimal place, so I'm going to put the whole number on my calculator. It's always a really good idea to do that. And then I'm going to round it to one decimal place, and that will be 24.6. And I usually write 1 dp afterwards. Okay, so that's question 2. Question 3. A sofa has 6 identical cushions as shown, 95 by 80 by 18 centimetres. The cushions are covered with a protective spray, and the protective spray is in cans, and it says that spray in the can covers 4 metre squares. So we've got to work out how many cans are needed to cover 6 of these cushions. Well, let's have a look. So I would suggest that we work out the surface area of one cushion, and that would be 2 of these faces, so that would be 2 lots of 18 by 80, and then 2 lots of these, which measure 18 by 95, and then two of these, the top and the bottom of the cushion there, which is two lots of 80 by 95. So I've just worked out in metre squares each of those individually, so I'm going to add them all up. 2,880 plus 3,420 plus 15,200, and that is 21,500 centimetre squares. Let's create a little bit more room here. So I'm going to convert 21,500, that's one cushion, and I'm going to times that by 6, and then I'm going to convert into metre cubes, so bear with me. So 21,500 times 6, that'll be 129,000 centimetre squares. But how do I change that into metre squares? Well, 1 metre times 1 metre is 1 metre square, and because we've got metres times metres, so 1 metre is 100 centimetres, and that would give me 1, 2, 3, 4 powers of 10 centimetre squares. So that's 10,000. So I've got to divide this number by 10,000 basically. So divided by 10,000, and that will convert to metre squares, and that gives me 12.9 metre squares. I then would have to divide that by 4, because that's what each can would have. Divide that by 4, and that gives me 3.225 cans, so I'd have to buy 4. Right, so let's have a look at the next part. Let's move some of this writing away. It says the information on each label is inaccurate. The spray in each can covers 10% more than 4 metre squares. How will this affect the number of cans needed for the 6 cushions? Well, let's not worry too much. We'd still have the same amount of area to cover. So we're going to have 12.9 metre squares to cover, but now the can covers 10% more, so 10% of 4 metre squares is 0.4, and we just add that on, so we'd get 4.4 metre squares, and of course use your calculator if you need to. So 12.9 divided by 4.4, so 12.9 divided by 4.4 gives me 2.9318 recurring. So I would have to buy 3 cans to do the job. I can't just buy 2.9318 recurring cans. It's not possible. So I have to buy 3 cans instead. So how will this affect the number of cans needed? So hence less cans needed. Okay, just to be sure we're going to get all the marks. Right, okay, let's move on. Question 4. A is the column vector 1, 4, and B is the column vector 3, 2. So that's basically telling you the gradient. It's telling you what rule to use. So if you want to go from a particular place and you want to move the vector A, it just means you go along 1 and up 4, okay, to get to where you want to go. And you'd write the vector like so. Now we want to do A plus B, so we have 1, 4 plus 3, 2, and that's nice and easy. That's just going to give us 4, 6. Then we've got 2A plus 3B. Well, that's just 2 lots of A plus 3 lots of B. These numbers here, by the way, are scalars. It means they have no direction. Okay, they're just numbers. They have no dimensions. So we'd be left with here 2 lots of this and 2 lots of this, which is 2, 8, plus 3 lots of this and 3 lots of this, which is 9, 6, which would give us 11, 14. Now, there's a diagram drawn here, and it says C, the vector C, is drawn on the grid. From this starting point here, and we could have started wherever we wanted to, but it's telling us to start from here, we've got to draw the vector 3C. So it'll be 3 times something. We'll call this Q and R. And don't forget, this part is the gradient, and this part's just a number. So 3C is going to have the same gradient as the vector C. It's just going to be 3 times more. So can you work out what it's going to be? Well, the rule here was go along 3 up 2 from this point here, which could have been anywhere, by the way. But this one is 3 times the amount. So we would have 9, 6. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6, we'd end up here. Now, I'm going to try and draw a line here, I think, with this app. So let's have a look. I'll do it in this colour. So I reckon that would be my answer, and I'd label that 3C, and I'd underline that. The reason they're not underlined here is because they're in bold. Okay, so if you can't write in bold, well, you can, but it doesn't look that good. It's not so noticeable. So really, you should underline your vectors when you draw them. Okay, so not too bad a question there. Question 5. It says the height in X centimetres and the width in Y centimetres of TVs are in the ratio 9 to 16. Use this information to draw a graph to show the relationship between the height and the width of TVs. It says use values of X from 20 to 80. Now I think this question is quite tough, but again, if I say that, I mean tough for me as well. I think the strange thing about this one is to watch out for is that this starts at 2020 here. So although we've got the ratio, and I'm going to put this as X to Y. So if we went 9 on the X and 16 on the Y, that wouldn't show up on the graph. So why don't we just times, say, both sides by 4 here, so we'd have 36 to 64, and I can definitely plot that. So 36 along 64 up, so that's 70, so there. And then if I just double this, 72 to 128, that should be fine as well. So 72, be careful whatever you do with a scale, 72 to 128, 120, 130, there. It's weird when you do these, I've not done scales for a long time, so I think that's right on there. I'm sure if it's wrong you'll tell me. In fact, I'll just zoom in and make sure. So 36, 64, yeah, because that goes up in twos, don't forget here. 62, 64, 66, 68. And then the other one, 72 along, and then 128, so nearly 130. Yeah, that should be fine. I'm then going to draw my line straight through there, so I don't want to mess this up. So and let's have a look as well, by the way, as look, use values of X from 20 to 80. So we're lucky that we didn't try and be too clever and go, say, I don't know, 7, 8, 9 times. We could have 9 times 9 and got 81, and then 9 times 16, which would be 90, 144, and if we'd have plotted that, we'd have been wrong because we couldn't have gone to there anyway. So, put our line through here. Here we go. Draw the line, and then we can put this through those 2 points carefully. You'll do it more carefully than me, I'm sure. And then let's answer the next part of the question. A TV has a width of 90 centimetres. So here's 90 here. Use your ruler. So if you look at 90, use your ruler and then go along, and I would say around here, I would say 51 centimetres would be my answer there. I'm sure you'll probably have something in the range from, I don't know, 48 to 52 or something a bit wider perhaps. Okay, so that would be my estimate, and as long as you show your dotted line there, use the ruler properly, you can't really go wrong. Question 6. Work out the value of x. Well, in the playlists under trigonometry, I go into a lot of detail on the unit circle and how to really understand what you're doing with trigonometry. So it'd be lovely if you check those out. I'm not going to go into a huge amount of detail now because I'll just get loads of complaints. But if you want to be taught how to do it properly, then watch my videos on trigonometry, and by the time you finish with those, you should know it inside out. A very simple way of approaching these is to use the notation of SOHCAHTOA, which I don't like teaching unless people understand where it came from. But again, that playlist under trigonometry will explain. In this situation, we have our opposite here, and opposite the right angle is the hypotenuse. So this would be the adjacent. And what I would do here is, I would say, well, I've got my opposite and my hypotenuse involved, so this would be to do with sine. So that would mean that the sine of 30 equals opposite over hypotenuse. So that means x would be equal to 18 sine 30. Now you should know what the sine of 30 is. The sine of 30 is the same as the cosine of 60. And again, those videos explain why. Because 30 and 60 make up to 90. And cosine means complementary sine. Okay, so it means the angles would add up to 90. So I know that's the same as 18 times cos of 60, and cos of 60 is a half. So we're going to get 9 there. If you don't know that, then just please use the calculator. It's absolutely fine to do so. So I reckon we should just write 9 centimetres here. Question 7. A train travels from Madrid to Malaga at an average speed of 183 kilometres per hour. So speed is distance over time, because we had kilometres over hours, so that makes complete sense. And we know that's 183 then, so we're given that, that's good. And the train leaves Madrid at 08:40 hours and arrives at Malaga at 11:28 hours. So you can use your calculator if you want, if that helps. So to get to 9, then we'd have 20 minutes. And then to get to 11:28, that's 2 hours 28 minutes. So that's 2 hours 48 minutes. So I need to just write the hours in here because that will just confuse some of you, including myself. So 2 hours 48 minutes. So 2 hours is 120 minutes plus 48 more minutes will be 168 minutes. So in our formula, speed equals distance over time, we had the average speed. We want to work out the distance, and luckily we now have the time. So all we're going to do is make sure that our units are correct. So the time there is in minutes, so we want to convert that into hours. So that's one thing we've got to be careful of, because our speed was kilometres per hour. So we're just going to do that little conversion here. So 168 minutes, well, how do we convert that into hours? Well, yeah, we'll divide it by 60, because there are 60 minutes in an hour. So 168 divided by 60, and that gives us 2.8. So what do we need to do from here? Well, what we've got is, if we look at our units here, so if I write this out again, that will be 183 kilometres per hour, and this was always been in kilometres. This, however, was minutes, and now this is what we wanted in hours. So we've got D, which is in kilometres, over 2.8 hours. And I'm just going to show you why this works. So if I want to get this unknown, I've got to multiply both sides by 2.8. So I'll have 183 times 2.8. But look at the dimensions here. I'm going to have the kilometres per hour that was already here. And look, this hours is going to come up here as a dimension. And then they're going to cancel. And that is why I'm left with a distance, okay, in kilometres as needed. I think some people forget the dimensions and how they can help us. So if we look at 183 times 2.8, I get here 512.4 kilometres or kilometres. Okay, so if the explanation was a bit too long, then just skip forward a bit. You can press the left or right arrow key to go forwards and backwards. Okay, so 512.4 kilometres. Question 8. A hollow cylinder has radius r centimetres and height 6r centimetres. 3 spheres, also of radius r centimetres, are put into the cylinder as shown in the diagram. We've got to work out the proportion of the cylinder that is not filled by the spheres. Okay, so the cylinder, the volume of the cylinder is going to be pi times the radius squared times the actual height. So that's going to give us pi times r squared times the height, which is 6r as given in the question, don't forget. And that gives us 6 pi r cubed. For the spheres, well, we have 3 of them, times, and we can just substitute into this lovely formula that we've been given, which will be given, I'd say, nearly all of the time, if not all of the time, in the exam. So 4/3 times pi times r cubed, and that gives us 4 pi r cubed. So if we want to see how much of the space as a proportion is filled, yes, is filled by the spheres, we would do 4 pi r cubed out of the total volume of the cylinder, which would be 6 pi r cubed here. These cancel, and 4 divided by 6 is 2/3. So that's 2/3 is filled. So yeah, you can work it out, 1/3 not filled. The next part of the question says, the height of the cylinder is increased by 2r centimetres. So now we'd have cylinder would be pi times r squared times, well, it would be 8r because it would be 6r plus 2r more. And that gives us 8 pi r cubed. And now for the spheres, we've got 4 of them, so 4 times 4/3 pi r cubed, and that gives us 16/3 pi r cubed, or 16/3 of pi r cubed, and we want the proportion of the spheres to the cylinder. So we would have 16/3 pi r cubed, and here we'd have 8 pi r cubed. So these would cancel, and we'd have 16/3 divided by 8 is the same as 16/3 times 1/8. You can do all this on the calculator, by the way, just this fraction part, and we'd be left with 2/3 filled, and so again 1/3 not filled. So my idea would be that if Malcolm says there is no change in the proportion of the cylinder not filled by the spheres, is Malcolm correct? Yes, and you can say C workings, and the examiner can have a look at that. Okay, so for 1 mark, I think that's quite tough, really. I think some people will find that quite difficult. Question 9. Quite a difficult question here, I think, but let's have a go. Let's put a grid here with some of the information and see what we can do from there. So if we have alloy A, B and C, and we'll have density, volume and mass along here. Let's see what information we do have, and we have that 1 meter cube of alloy B, so 1 meter cube, that's a volume, so has a mass of 8,600 kilograms, but we also know the ratio of A to B to C is nearly made a bad mistake there, is 13 to 15 to 21, and that's the ratio of the densities, so I put that in this row here. Okay, so I think we're good to start the question now, and let's not forget that density is mass per given volume, so we can work out the actual densities here of each of them, because we've got the ratio at the top there along here. So this one is just going to be 8,600 kilograms per meter cube, because don't forget mass is in kilograms, volumes is given in meter cubes. Okay, so that's the first thing. The next thing I would do, this is just my preferred way, is I would divide this one here by 15 and then do the same in proportion to all of the others. And then if I wanted to find a volume, so the density for the volume of 1 meter cube of alloy C, for example, I would just do 8,600 times 21/15. Now 21/15 is cancels down, you don't really have to, but that's 7/5. And the reason that's important is because this tells you what 1 unit is going to be, and it kind of shows you what I have to do to 1 unit to get to working with density of alloy C. So what mass do we get? So let's do 8,600. 8,600 times 21 divided by 15. That gives me 12,040 kilograms. Okay, I'll put kilograms in here if it helps. So we know here that the density of, this is all to do with the volume of 1 meter cube. I'm going to keep them all as 1, and then I'm going to times them up later on. So this will be 12,040 kilograms per meter cubes. You can write that as kg m to the -3 if you want, they're both the same. And then for this one, for 1 meter cube, I'm going to times what I knew 1 was worth for alloy B, because don't forget I could make this 1 here, and then I can compare. So that's going to be 13/15 of 1. So it's going to be 13/15 of 8,600 in proportion. So 8,600 times 13 divided by 15, that gives me 7453.3 recurring kilograms. So the density of 1 metre cube would be 7,453.3 recurring kilograms per metre cube. And then we're off to get the rest of the question right now then, because we want to work out the difference between the mass of 5 metre cubes of alloy A and 3 metre cubes of alloy C. Now if I use a different colour here, our masses are clearly given here in kilograms for each one. So if we want to do the mass of alloy A, then that's just going to be 7453.3 recurring times 5, because we had it for 1 metre cube and we want it for 5. So I'm going to do that on the calculator. So that's 7453. I'm just going to do lots of 3's afterwards. It's just easier doing that way. Times 5. So do lots of 3's after the decimal point, and that'd be just as good. And that's going to give me 37266.6 recurring kilograms. And then the mass of alloy C, 3 metre cubes of it, will be just 12,040, and I can do that in my head. So that's 36,120 kilograms. You can do it on the calculator. And what you have to do is find the difference between those masses. Okay? So in my table here, don't forget this is 1 metre cube, 1 metre cube, 1 metre cube, if that helps. Okay, so we're just going to do the difference between these two, and I'll do that on the calculator. So 37266.6 recurring minus 36120, that gives me 1146.6 recurring kilograms. Now you can probably sense that I'm a bit reticent on this question. I'm not really confident on it because it's making my brain go in overdrive. But it's the first time I've seen the question, so I think if I was doing this paper I would worry about this one and probably leave it till the end. So it wants it now to 3 significant figures. So 3 significant figures, so we're looking for here, so we're looking at the nearest, not unit, 10, the nearest 10, so we want 1,150 kilograms. So one of the hardest questions I've seen for a very long time, but some of you probably find that really easy. Well done if you do. Question 10. Write the following numbers in order of size. Start with the smallest number. Right, so why don't we just get them as decimals, I think. So we'll have, this one's easy to write, that's 450. This is 0.45 times 10 to the minus 1, and all that means is it's just 0.45 divided by 10 once, because if you have 10 to the minus number, that means you're dividing by 10 3 times, and if it's plus 3, it just means you're timesing by 10 3 times. So don't worry about this too much. You can just change this 10 to the minus 1 into 1/10 if it makes you feel better. And then you can see, look, 0.45 divided by 10 is the same as 0.45 times 1/10. So that's just going to be 10 times smaller. So that's going to be 0.0. So I'm going to label these A, B, C and D. And so here's my C here. I'm now going to do D. and that's going to be 0.045, and I'm just going to put some noughts in here to help me. Then I'm going to look at this one, so that's 4.5, well, divide by 10 three times, 1, 2, 3, so that's going to be B, and that's going to be 0.0045, and then lastly 0.045 times 10 three times, 1, 2, 3. Okay, so that's going to be 45. So there's A, and that's going to be 45. And I'm just going to put some zeros here. Okay, so I've got to do the smallest first. Well, I hope you can see that the smallest one is going to be B here, because if we look at the tenths, the hundredths, it's got 4 thousandths, whereas this one here has 4 hundredths. So this one's going to be smallest. So 0.0045 is the smallest, so I guess get rid of that one. The next smallest one is this decimal, obviously, so the next smallest one is 0.045. Then we've got 45, and then we've got 450. And all you have to do is just make sure that you just write the original parts out, not the numbers you've just arrived at. That was just to help you. So you must write, I believe, which one tallied with 0.0045. Well, that was B, which was this one, which was 4.5 times 10 to the minus 3. So we can cross that one out. Then we had 0.045, which was D, which was this one, which is 0.45 times 10 to the minus 1. Let's get rid of that one. Well, this one was the biggest, C, so we can put that one there. And then it just leaves this one, which was A, which is 0.045 times 10 to the 3. So sorry for the mess there, but that's the smallest to the largest. Question 11. It says an accurate scale drawing shows a map of an island. Unfortunately, this photocopied paper that you probably have may not be completely accurate, so I'm going to go with this distance that I've measured, and I've measured this to be, not a very good line there, but that will do. I measured that to be 7.5 centimetres, and that represents 56 kilometres. So 56 kilometres is 7.5 centimetres. So if I divide both sides by 56, then 1 kilometre is going to be 7.5 over 56, and that can be my scale factor of enlargement, because it says here that treasure is buried at point C on the island. Point C is 35 kilometres from A, so 35 times this scale factor that I've got here, that gives me, let me just put that in my calculator, so we've got 35 times 7.5 divided by 56, that gives me 4.6875, and the accuracy on your ruler to one decimal place, say 4.7 centimetres. So what you'd have to do with your compass is put your sharp point here, S for sharp, and then your pencil 4.7 centimetres, and I'm just going to say for argument's sake that it is, let's have a look, say up here somewhere, and I'm just going to have my pencil drawing an arc of a circle. So I'm going to give that a good go. It won't be brilliant, but let's just say for argument's sake it was something like that. Okay, so we know it's on there somewhere, and the reason I'm not doing it all the way around is because I can see here that it's a bearing of 300 from B. So I've got to turn clockwise 300 degrees, and again I haven't got a protractor, so I'm going to guess it. So 300 I would say is about 270 and 30, so I'm going to say about there, and then I'm going to draw another dotted line like so, and where they coincide I'm going to mark with a cross and call it C, just like it wants. Okay, so give that a try at home if you've got a paper from your teacher. Be aware that photocopiers work slightly differently, so you may not get the same answer. The paper that you'll get in the actual exam, they will, well, hopefully all be exactly identical. So I've used 7.5 for that first distance there, but that may not be what you have. So you just substitute what you measured originally from A to B as that number and use that number instead of 7.5 all the way through. So I hope that makes some sense to you. So that's question 11. Incidentally, I did ask a colleague about this, and apparently on the actual paper, the mark scheme suggests that this number here should be 8 centimetres measured accurately. So I think this would change this to 5 centimetres, and that's how far this point would have to be away if you draw your arc of the circle. So instead of going 4.7 away, you'd go 5. But see what your paper says, and like I said, just use that number all the way through. Okay, that's definitely that question done now. Question 12. There are 24 girls and 12 boys in a club. One girl and one boy are going to be chosen to go to a meeting. Work out the total number of ways of choosing a girl and a boy. So the first girl could choose to be paired up with any of these 12. Okay, so there'll be 12 ways for girl 1, and then can you see there'll be 12 ways for the second girl as well, and there'll be 12 for each of the 24. Don't get confused thinking that if the first girl goes to a meeting with the first boy, that then the second girl and the first boy can't be chosen. G2 then B1 is an outcome, okay? At the end of all of the choices that you can possibly put out there on the table, then you just choose one of those pairings, okay? So it's not like if you take a bead out of the bag, it's already done, okay? So you're kind of replacing these things, okay? So look at it like that. So basically for each of the 24 girls, they have 12 possible choices, so it's just 24 times 12. So on your calculator you should get 288. Question 13. Let's expand and simplify this expression. Well, let's start with these two brackets first. We don't have to start with those two, we could have started with any two because multiplication, the order doesn't matter. So we'll start with x plus 2 multiplied by 2x minus 3, and that will give us 2x squared minus 3x here, 4x, and then minus 6. So that gives us 2x squared plus x minus 6. And so that's what this is worth. And then I'm just going to times that by 3x plus 1. So I'm going to get 6x cubed, 2x squared, 3x squared, x minus 18x, and then be careful, minus times the positive is negative 6. So I'm going to have 6x cubed plus 5x squared minus 18x plus x is minus 17x minus 6. Part B, we've got to simplify this expression here. So we'll have n to the 4 all divided by n to the power of a half. And the rules of indices would tell us to subtract these powers. So it would be n to the 4 minus a half. So I would write that as 8 halves, which is what 4 is, minus 1 half. So it would be n to the 7 halves. Question 14. I think this is quite a tricky question. We're given that the ratio of C to D is 1 to 9, but we're also given that A equals root 7 plus root C, and B is root 63 plus root D. So we can work out here that the ratio of A to B would be root 7 plus root C to B, which is root 63 plus root D. But hold on a minute, isn't it that D here is 9 times more than what C is? So we can say root 7 plus root C is the same as, is the ratio to root 63 plus root, well, D is 9 lots of C. Now, from here, we can say that root 7 plus root C, and then that will be the ratio to root 63. Now, root 63, 9 sevens are 63, so that would be root 9 times root 7 plus root 9 times root C. So we're nearly there. So we're going to end up with, and I'll just expand this a little bit so you can see what's going on. We're going to end up with here root 7 plus root C to 3, because that's what the root of 9 is, root 7 plus 3 root C. So we'll end up with root 7 plus root C in the ratio to 3 lots of root 7 plus root C. So it looks as though if we did it this way, I think you can see quite clearly now, we end up with the ratio 1 to 3. Okay, not a fabulously easy question there, not for me anyway, but maybe some of you find that quite easy. Question 15. Two solid cones are mathematically similar. Okay. Cone A has a volume of 120 centimetre cubes and cone B has a volume of 960 centimetre cubes. Well, first of all, 960 divided by 120 is 8, which of course use your calculator by all means. So we know the volume scale factor is 8 times as much. So we can have length scale factors, area scale factors, and volume scale factors. If we have a volume scale factor of 8, that means we really should work down to the length as quickly as possible, and then we can work up to the area scale factor. So what does that mean? Well, if my volume scale factor is 8, then to get a volume I have to cube a length, don't I? So to get from a volume to a length I have to cube root. So if you do the cube root of 8, which you can do as this, or on your calculator this, 8 to the power 1/3, you're going to get 2. And then what do you do to a length to get an area? Well, you square the units of length, don't you, to get areas. So you'd have to do 2 by itself, so 2 times 2, which would be 4, or 2 to the power 2, which would be 4. So we know that the ratio of the surface area of the cone, so if it involves the area, this part here in the base, the ratio of that is going to be in the ratio of 1 for the small cone to 4 for the larger cone, okay? Because that would be the scale factor for the area enlargement. Whether it's surface area, the curved or flat, it makes no difference. Question 16. There are 8 cards and Erin puts 8 cards in a bag. She takes at random a card from the bag and does not replace it. Okay, so no replacement here. Erin then takes at random a second card. Okay, we've got to calculate the probability that the number on the second card is double the number on the first card. Okay, so that only leaves us with the possibility of choosing a 2 first, then a 4, or a 3 first, then a 6. So let's have a look at the probabilities of each of these. Well, for Erin to choose a 2 first, then there's one of those 2s out of 1, 2, 3, 4, 5, 6, 7, 8 cards. But what's the probability of then choosing a 4 with no replacement? Well, that would be, get this right, that would be 2, because there's 2 4s here, out of 7, because don't forget 1 has already been chosen. And of course we multiply these out, and that would give us 2/56. Likewise, for the next possibility, the probability of getting a 3, well, that would be 2 choices out of 8, and then for getting a 6, that would be 3 choices out of 7, because 1 is already chosen, and that gives 6 out of 56, and then we pick these 2 together and add them. Just like we do in a probability tree. I just didn't do a tree this time, there wasn't really any need for it. And we'd have here 8 out of 56. We could cancel that down to 1 in 7. You can use your calculator to help you for that if you want, but either of those are fine. I generally like keeping the denominator in this form, in the non-cancelled form, because it gives me a total number of possibilities in the context of the question. Okay, whereas this 7 doesn't do that for me. Question 17. A, B and C are positive integers such that A is greater than B is greater than C, and n is the largest 3-digit number that has the digits A, B and C. So the hundreds would have to be A, which is the biggest number, then the tens would have to be B, and the units would have to be C. That's the largest. And then the smallest is K, and then I'd have to reverse these, wouldn't I? The least number of hundreds, so 100C, B would still be in the middle, and A would have to be last, and that would be the smallest. And it says use algebra to show that the difference between n and k. So the difference between n and k will be just n minus k. So that gives 100 minus 100c. So 100a, sorry, minus 100c. 10b, take away 10b is just nothing. So that would cancel. And then C minus A. Well, that would give me 100A minus A, which is 99A, and then minus 100C plus C, don't forget, will be minus 99C, and I can factor out a 99. So no matter what A and C are, the difference between them, I'll always be timesing by 99, so it will always be a multiple of 99, so that's good. Let's look at the next part. I think in part B, if A is still greater than B, even if B equals C, then when we come to find the difference, I would say the answer is yes, because I should have a capital B there, because the B's cancel in the middle when you do the taking away. So I think you'd be left with something like, you can try this yourself, just look at the workings from before. I think you'd get 99 lots of A minus B instead. But whatever A is and whatever B is, A being greater than B, don't forget, you're going to get a number which is always times by 99, so it's always still going to be a multiple of 99, hence me saying yes. So a little tricky, but just give it a try. You've got to put pen to paper yourself and try these questions. So see if that makes sense to you, because that's what I think it is. Question 18. The histogram gives some information about the weights of some fish, and the number of fish with a weight between 400 grams and 450 grams is 7 more than the number of fish with a weight between 250 grams and 300 grams. So I think what I'm going to do is I'm going to draw a table of values here. So I'm going to have class width, frequency density, and then frequency, and then I'm going to put these in a table. So let's have a look what we've got here. We've got a class width of 50, a frequency density of 10. So the frequency is the area of the bar, so that's 500. The next one, the class width is 50. The frequency density is 8, because they go up in twos here, so that's 400. The next one, class width 100, and then 2, 4, 6, so that's 600 altogether. The next one is 50. The height here is 12, 14, that's 15. So that's going to be 750, so that's going to become key later on. Then we've got 150, but then 2, 4, 5, so that's 750. And then we've got 1, 2, 3, 400, and then a height of 1, so that's 400. Now, when it said that the number of fish with a weight between 400 and 450 is 7 more than the number of fish with a weight between 250 and 300 grams, we can use that information now, because we know that between 450 and 500 was this one here, and 250 and 300 was this one here. So it looks as though 350 as a frequency represents 7 fish. So if we want to calculate the total number of fish, then I would add all these up on my calculator. I'm just going to do it by hand, it's probably going to be quicker. So we're going to have 0, 0, carry the 1, 5, 9, 15, 22, 29, 33, 34, so 3,400. Now from this information, a frequency of 350 was 7 fish, so 1 fish would be 350 divided by 7, which is a frequency of 50. So how many 50s go into 3,400? Well, you can use your calculator and you'll get 68 fish. So I would say 68 fish for this part here. For part B, I've not done these histograms for a long time, but let's have a look. For part B, I've put in blue here how many fish, because we said that a frequency of 50 was 1 fish, wasn't it? So each of these little squares represents 2 fish. So 2, 4, 6, 8, 10, 8, 12, 15, 15 and 8. Okay, and remember how we got that? Because we found out that difference was worth 7 in the question. So if 7 was 350, 1 fish was an area of 50 or a frequency of 50. Okay, so you've got to be really clear of what that means. So I've put in blue how many fish is represented here. Now if we want the median, doesn't that mean that if we have 68 fish, there's going to be 34 this side and then 34 this side? So we want to go to the 34.5 value. So how do we get to 34.5? Well, we count from left to right. So we've got 10 so far, plus 8 is 18, plus 12 is 30, so we want to go 4.5 into here, and this is worth 15. So if we do 4.5 over 15, which on the calculator is 9 over 30, which I'll cancel down as 3/10. You can do that on the calculator. I want to go 3/10 into this class width, okay, 3/10. So we're starting at 400, which is our weight. So we're 400 plus 3/10 of what this class width was, which was 50 grams. So 3/10 of 50, again you can do that on your calculator, is 3 times 5, that is 15. So we have 400 plus 15. So I would say 415 grams. There are some good videos on YouTube that explain how to do this as well. This is called, I believe it's called interpolation or extrapolation. I would say it's interpolation because you're looking between values and you're saying, right, okay, I want the 34.5 value, and you just count along and do the fraction of the bar or the frequency part that you need, and then add it on to where the nearest one was. In this case it was 400, and we had to go 3/10 of the way in, because 4.5 represented 3/10 of 15. So I think that's a tough question actually, probably the hardest one out of the whole of these 3 sets. And there's probably another part to go, I think, so I'll just have a look if there is. Yeah, there is, so we'll do that bit now. So we'll write this answer in clearly in the box for this bit, and so we said 415 grams, didn't we? Well, this last part, it says, give a reason why your answer to part B, I, is only an estimate. Well, again, this is not particularly my strength, and some of you might want to comment on this a bit more than me. But when you look at the distribution of the fish, you know when you do like a class interval, you're kind of like don't know where the masses, in grams, the weight of those fish in grams lies. We assume that there's some kind of like even distribution or some kind of like central tendency. Hence, when we're trying to find the mean, for example, we just assume the midpoint, okay? But we don't know how those fish are distributed exactly in that class interval, so that's why it's an estimation, and I've put that here. I've said only an estimation because it's dependent on the distribution within that particular interval. So we don't know this information exactly, we've had to put it into class intervals. So I hope that makes some sense to you. If it doesn't, please comment, and if I think it's a decent comment, I'll put it up there, and then you can read the comments about it, because there's bound to be many people way better than me at this stuff. So that's my last question of the 3 papers, of the higher ones anyway, and that's quite a tough one to end on for me anyway. Okay, so I hope you did well in this paper. Question 19. If we have 2x squared minus 5x minus 12, and that's greater than 0, let's see if this factorises. Factors of 12, I'll go with 4 and 3, and then we're going to have minus 8 plus 3 would give us minus 5. Now, the shape of this quadratic, because this value here is positive, is going to have this nice shape here. So I'm going to put x is 4 on a number line, and x is minus 3 over 2, which would be the solution points here if it was equal to 0. So I'm going to put those on a number line, and then I'm going to just draw this shape through it. Doesn't matter if it's a bit inaccurate. And then I'm going to put my number line clearly on here, okay? And then I'm going to read what it says. It says, where is this function, i.e. the green part here, where is it more than 0? Well, it's more than 0 when x is greater than 4. And it's also more than 0 when x is less than minus 3 over 2. So they would be my answers for that question. Question 20. Asmol rolls a biased dice, an unfair one, and spins a biased coin. The probability that the coin will land on heads is 0.55, and the probability that the dice will land on 6 and the coin will land on heads is 0.11. So we know that the probability of tails would be what makes it to 1, so 0.45. And we've got to work out the probability that the dice will land on 6 and the coin will land on tails. Well, if we had to work out this probability here, we'd have to multiply two things together, wouldn't we? We'd have the probability of getting a 6 on the dice, followed by the probability of heads, which luckily we already have from here. And we know the answer is going to be 0.11. So I think the chance of getting a 6 here can be easily worked out, because if the probability of getting a 6 multiplied by 0.55 is 0.11, then the probability of a 6 is 0.11 divided by 0.55, and on your calculator that will give you, I'll write it up here so you can see, that would give you 0.2. So probability of getting a 6 is 0.2. However, we want the probability of getting a 6 and then a tail. So on the tree diagram, we would have had probability of 6 would be 0.2, because don't forget it's biased, it's not a fair dice. And then we'd have to multiply that by the probability of getting a tail, but we have that anyway. So on the calculator, if we multiplied those together, we get our final answer of 0.09, and I'll just put an orange squiggle around that so you can see that would be the answer we'd be looking for. So it's a matter of just reading the question and just using a bit of common sense. You don't have to draw really complicated diagrams or anything, and try not to think too hard about the question. All the information is there for you. Question 21. We're given a function here, 1 over x plus 2 plus 1 over x minus 3. We've got to work out f of 5. So we just have to put 5 in place of x basically. So f of 5 will be 1 over 5 plus 2 plus 1 over 5 minus 3, which will give us 1/7 plus 1/2. And you could use your calculator, I guess, for this. I'm not going to. So I'll just get 2 plus 7 over 14, which would give me 9/14. Okay? So that would be my answer to the first part. Well, let's have a look at part B. It says write down a value for x for which f of x is not defined. Well, I've done a little graph here, so it's a bit small, but I hope you can see it. This is our y-axis, and this is our x-axis here. Basically, to not be defined means that if I take a value of x, i.e. my domain, what goes in to the function, just like 5 here, if I find a number that doesn't give me an outcome, i.e. a range value, i.e. the function could here, for example, when 5 went in, look, something nice came out, something on the number line. Okay? Whereas in this case, if I put 3 in here, then nothing's going to come out. It's going to be undefined. That's because here, if that's 1 over x minus 3, when x takes on the value 3, we'd end up with 1 divided by 0, which is not defined. Okay? So one of the values could be 3. I'll give the other one as well, and you can probably see it from the graph. It's when x is negative 2. Because here, negative 2 plus 2 is also 0, and you can't do 1 divided by 0, it's just not defined. So these points here on the graph are called asymptotes, just in case you were interested. Right, let's have a look at the next part. Part C. Given that f of x equals 4, Well, don't forget, f of x was 1 over x plus 2 plus 1 divided by x minus 3. If it's saying that's 4, we've got to try and find the possible values of x. So we've basically got to solve this equation here. So first things first, let's create a little bit of space for us here. It's 5 marks, it says, so we're going to get these fractions having the same denominator. So I'll do a little bit more detail here. So we're going to times this one top and bottom by x minus 3, which is really like timesing by 1, which doesn't change the value. And then I'm going to times this other fraction top and bottom by x plus 2. Again, that's like timesing by 1 because x plus 2 divided by x plus 2 is 1. And that's going to be equal to 4. So I have a common denominator now of x minus 3 times x plus 2. And what do I have on my numerator? Well, I have x minus 3 here plus x plus 2. And that's equal to 4. So on the numerator, I now have 2x minus 3 add 2 is minus 1. And then underneath, I'm going to have x minus 3 times x plus 2 equal 4. What I'm going to do now, I'm going to create a lot more space for us to have a look at. I'm going to times both sides by the denominator, so I'll end up with 2x minus 1 is equal to 4 lots of x minus 3 times x plus 2. You could have expanded that at any point. I'm just going to do it now. So you'll have 2x minus 1 equals 4 lots. I'm going to use a square bracket here. X squared plus 2x minus 3x minus 6. So 2x minus 1 would be 4 lots of x squared minus x minus 6. So 2x minus 1 becomes 4x squared minus 4x minus 24. I'm going to get all the x squares on one side, all the x and all the constants. So minus 4x minus 2x, and then minus 24 plus 1. That's minus 23. From here you've got many different options that you can take now. I think one for me would be, I would probably do completing the square. So I'll divide everything by 4 and just switch the sides over. So I'd have x squared minus 6 over 4x minus 23 quarters equals 0, which is x squared minus 3x over 2 equals 23 quarters. I then complete the square here, so I want half as much of this, so it's 3 quarters, all squared, minus 9 sixteenths equals 23 quarters. If you want to see completing the square, I've definitely got a playlist with algebra with loads of questions in there of how to do that. And then we've got x minus 3 quarters all squared is 23 quarters plus 9 sixteenths. Now if I want to get this in quarters, then I'm going to have 92 sixteenths plus 9 sixteenths. Of course you can use calculators whenever you want, so that's 101 sixteenths. So what have I got then? Well, I've got x minus 3 quarters all squared equals 101 sixteenths. I'm going to square root both sides. And don't forget the square root can take on a positive or negative value. I'm then going to add 3 quarters to both sides. And that will give me the answer here. Now it wants it in the form p plus or minus root q all over r. So I'm going to have 3 plus or minus root 101 over 4. And that would be my answer. An alternative here would be, you could just use the formula. So x is minus b plus or minus the square root of b squared minus 6 squared is 36 minus 4 times a times c, which is minus 23, all over 2a, which would give me 6 plus or minus 36. Be careful, minus times the minus would give you a plus. 4 fours are 16 times 23, all over 8. So we'd have here 36 plus, well, 23 times 16, you can use your calculator, and I'm going to get 368. And then here we'd have 6 plus or minus 368 and 36. Well, that gives me 404. And then the nice thing about this is I can take 4 out as a factor of here, so I'd have the square root of 4 times the square root of 101 over 8. And then, can you see the square root of 4 is 2, so I'd have 6 plus or minus 2 root 101 over 8. And even nicer about this, all of these cancel by 2. And I'm just left with 3 plus or minus root 101 all over 4, which I believe, if I maximise this, if I can find it, let's see, there it is. That was our previous answer that we had before, so I can put them underneath each other, and this one was also 3 plus or minus root 101 over 4. Okay, so I like doing lots of algebra like this. You just have to do loads of practice on them because they're all the same. Completing the squares, very predictable. You just have to do quite a lot of questions. And like I said, I've got quite a lot of playlists, as have plenty of other good people on YouTube as well. So don't just stick to what's on the exam. Look elsewhere and look for good questions, and then just try a whole load of them. Okay, so that's that one done.